Welcome to AI Frontiers, where we explore the cutting-edge research that's reshaping our understanding of machine intelligence. Today we're examining 15 groundbreaking papers from July 17, 2025, that collectively reveal AI research at a critical crossroads. These aren't just incremental improvements, but fundamental investigations into the nature of machine intelligence itself, asking questions that could determine whether we're on the path to artificial general intelligence or simply building increasingly sophisticated pattern-matching systems. Picture this scenario that should make us all pause. You're interacting with the world's most advanced AI system, and you ask it to solve a seemingly simple math problem. It confidently provides an answer that impresses you with its reasoning. But here's the twist. When you change just the numbers in that exact same problem, keeping everything else identical, the AI suddenly stumbles and fails completely. This isn't science fiction or a hypothetical scenario. It's happening right now with our most sophisticated AI models, and it reveals something profound about the gap between artificial intelligence and genuine understanding. This phenomenon demonstrates that what appears to be intelligent reasoning may actually be sophisticated pattern recognition, operating on memorized examples. Today's collection of papers paints a picture of AI research at a fascinating crossroads. On one hand, we're witnessing remarkable advances in areas like energy-aware evaluation, ethical reasoning, and human-AI collaboration. On the other hand, we're discovering fundamental limitations that suggest our current approaches might be hitting unexpected walls. It's like being explorers who've climbed what we thought was the highest peak, only to discover we're still in the foothills of a much larger mountain range. These findings will reshape how we think about AI development, moving us from blind optimization towards more thoughtful, sustainable, and genuinely intelligent approaches to creating artificial systems. To understand where we're going, let's first map the terrain of artificial intelligence research. Think of the field of AI as a vast ecosystem, much like a rainforest where different species occupy distinct niches, but all contribute to the overall health of the environment. Computer science artificial intelligence, or CS.AI as researchers know it, represents the canopy of this forest, the highest level where all the specialized branches come together to create something greater than the sum of their parts. This ecosystem encompasses everything from mathematical foundations that make machine learning possible, to cognitive architectures that enable reasoning, to practical applications that transform how we live and work. What makes it particularly vibrant is its interdisciplinary nature, drawing from mathematics, neuroscience, philosophy, psychology, and computer science to create systems that can perceive, reason, learn, and act. The first major theme emerging from today's papers centers on evaluation and benchmarking, the critical question of how we actually measure AI capabilities. Imagine trying to assess someone's intelligence by giving them only tests they've seen before. You might be impressed by their performance, but you wouldn't really know if they understand the underlying concepts or are simply good at memorization. This is exactly the challenge facing AI evaluation today. Papers like FormulaOne are pushing beyond traditional competitive programming problems to create entirely new challenges that test genuine algorithmic reasoning rather than pattern recognition. Meanwhile, VARMath introduces symbolic evaluation frameworks that can distinguish between true mathematical understanding and sophisticated valuation. These new approaches reveal that many AI systems that appear highly capable on standard benchmarks may be relying more on pattern matching than genuine reasoning. The second powerful theme is sustainability and energy awareness, representing the environmental conscience of AI research finally awakening. The generative energy arena paper represents a fascinating shift. Instead of just asking which AI model performs better, it asks which model users prefer when they know the environmental cost. It's like comparing cars not just on speed and comfort but on fuel efficiency and emissions. This theme reflects a growing recognition that as AI systems become more powerful, their environmental impact becomes a crucial factor in their real-world value. The findings suggest that when humans are informed about energy consumption, they consistently prefer smaller, more efficient models for most tasks. This challenges the assumption that bigger and more powerful always means better from a user perspective, and could reshape the entire AI industry's race toward ever larger models. A third major theme centers on ethics and safety, the question of how we ensure AI systems remain beneficial as they become more capable. This isn't just about preventing obvious harms, but about the subtler challenges of manipulation, bias, and value alignment. Several papers explore how AI systems can make ethical decisions, resist being used for harmful purposes, and maintain transparency in their reasoning processes. It's like teaching a powerful tool not just how to be effective, but how to be wise. The research introduces systematic frameworks for assessing manipulation risks and ensuring that AI systems can work alongside humans without compromising human agency or well-being. These frameworks become increasingly important as AI systems become more sophisticated in their ability to influence human behavior and decision-making. Now let's examine the specific findings that are reshaping our understanding of AI capabilities. Perhaps the most striking revelation comes from the FormulaOne benchmark, which tested state-of-the-art models on complex algorithmic reasoning problems. OpenAI's O3, one of the most advanced AI systems available, solved less than 1% of these problems, even when given multiple attempts and examples. The research on symbolic mathematical reasoning provides another crucial insight. When models are tested on symbolic versions of mathematical problems, performance drops dramatically. Average declines of 48% on AMC23 and 58.3% on AM24 suggest that many AI systems rely on memorizing specific numerical patterns rather than understanding underlying mathematical principles. These findings reveal that pattern matching does not equal genuine understanding, and current systems might fail catastrophically when encountering novel situations requiring true reasoning. For our paper of the day, let's dive deep into FormulaOne, Measuring the Depth of Algorithmic Reasoning Beyond Competitive Programming by Gal Beniamini and colleagues. This work represents what may be one of the most important contributions to AI evaluation in recent years. The researchers had a nagging suspicion that models achieving impressive scores on competitive programming benchmarks might not truly be demonstrating algorithmic reasoning, but rather recognizing patterns in problems they'd seen variations of before. To test this hypothesis, they embarked on an ambitious project to create an entirely new class of evaluation problems. Rather than using existing competitive programming challenges that might have appeared in training data, they constructed problems from the highly expressive framework of monadic second-order logic on graphs. These problems relate to practical large-scale optimization challenges in routing, scheduling, and network design that have real commercial value. What makes FormulaOne particularly ingenious is its connection to fundamental questions in theoretical computer science. Many of the problems are intimately related to central conjectures like the strong exponential time hypothesis, which concerns the computational complexity of satisfiability problems. This means that any AI system achieving significant progress on FormulaOne beyond known results could potentially contribute to resolving major theoretical questions, a remarkable feat that would represent genuine scientific advancement. The methodology they developed is both elegant and rigorous. Problems are generated to be simultaneously novel, mathematically well-founded, and practically relevant. Each problem requires multiple reasoning steps and deep understanding of algorithmic principles, making them ideal for testing genuine reasoning capabilities versus sophisticated pattern matching. The researchers also developed FormulaOne Warm-Up, a set of simpler problems from the same distribution, providing a pathway for future research to build toward the full benchmark. The significance of FormulaOne lies not just in its immediate findings, but in its potential to reshape how we evaluate and develop AI systems. By providing a benchmark that is both theoretically grounded and practically relevant, FormulaOne could guide research toward developing AI systems with genuine reasoning capabilities, rather than sophisticated pattern matching. It's like providing a North Star for AI development, pointing towards systems that can truly think rather than just compute. The current results suggest we may be further from artificial general intelligence than other benchmarks indicate. If AI systems are to contribute meaningfully to scientific research, drug discovery, materials science, or other domains requiring genuine innovation, they must be capable of the kind of deep algorithmic reasoning that FormulaOne tests. This work provides a framework for measuring true understanding and could be essential for creating AI systems that can advance human knowledge rather than just apply existing patterns. Looking toward the future, the research landscape painted by these papers suggests we're entering a new phase of AI development. Think of it as the difference between the early days of aviation, when inventors focused on simply getting off the ground, and the mature aerospace industry that followed, where engineers had to consider efficiency, safety, environmental impact, and a host of other factors beyond just the ability to fly. We're likely to see the development of more sophisticated evaluation frameworks that can distinguish between genuine understanding and pattern matching across various domains. Energy-aware AI development is poised to become a major focus, with researchers exploring more efficient architectures, training methods, and deployment strategies. The work on human-AI collaboration suggests a future where AI systems are designed from the ground up to work alongside humans rather than replace them. Perhaps most intriguingly, the limitations revealed by current evaluation methods suggest we may need fundamentally new approaches to creating AI systems that promote true understanding rather than sophisticated memorization. As we wrap up our journey through today's AI research landscape, several key insights emerge that collectively paint a picture of a field in transition. We've discovered that our most advanced AI systems may not be as capable as standard benchmarks suggest, particularly when it comes to genuine reasoning and novel problem-solving. We've learned that users care about environmental impact when making decisions about AI systems, potentially reshaping market dynamics. And we've seen that distinguishing between true understanding and pattern matching remains one of the most critical challenges facing AI evaluation. These findings remind us that the path to artificial general intelligence may be longer and more complex than many anticipated, but they also point toward more sustainable, ethical, and genuinely intelligent approaches to AI development. The researchers behind these papers aren't just advancing the state of the art, they're asking fundamental questions about what intelligence means and how we can create systems that truly serve human needs. We're just beginning to understand what we don't know about machine intelligence. This content was synthesized using GPT Anthropic CLAUDE-SONNET-4-202505514 for research analysis, with TTS synthesis powered by Deepgram technology and image generation through OpenAI systems. The content has been reviewed by human experts for accuracy, though some oversights may exist. All references to original research papers are provided for verification and further exploration. This synthesis represents our best effort to accurately convey the findings and implications of the research discussed, while acknowledging the inherent limitations of AI-assisted content creation. We encourage listeners to consult the original papers for complete technical details and to form their own interpretations of the research findings. I encourage you to dig deeper into these papers yourself and share your thoughts about the implications of energy-aware AI evaluation, the challenges of measuring genuine reasoning, or the future of human-AI collaboration. Join the conversation online using #AIFrontiers, and let's continue exploring these fascinating questions together. The future of artificial intelligence isn't just being written in research labs, it's being shaped by all of us who engage with these ideas and help determine how they're applied in the real world. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from archive preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses archivepreprinserver.org, content under its API terms of use. AI Frontiers is not affiliated with or endorsed by archivepreprinserver.org.